हेलो एवरीवन, कैसे हो आप लोग। आप सभी का हमारे यूट्यूब चैनल पे बहुत बहुत स्वागत है। ओके, वेलकम यू ऑल इन माय यूट्यूब चैनल। और टुडे वी आर डिस्कसिंग अबाउट द न्यू टॉपिक ऑफ केमिकल थर्मोडायनेमिक्स। द टॉपिक नेम इज हीट कैपेसिटी। ओके, फर्स्ट पॉइंट इज व्हाट इज द हीट कैपेसिटी। हीट कैपेसिटी इज द सिस्टम टू गेन द हीट टू रेज its temperature by 1 degree Celsius. Okay, if we consider one system, okay, like here is the system. Okay, the system initial temperature will be, the system initial temperature is, suppose we can take 25 degrees Celsius. Okay, if we rise temperature from 1 degree Celsius and the final temperature will be 26 degrees Celsius, and this phenomena is known as the heat capacity. Okay, you can also write down the definition of heat capacity. It is the capacity of the system to gain the heat to raise temperature by 1 degree Celsius. Okay, this is the simplest definition for the heat capacity. If you are considering one system, if the initial temperature will be the x, and in x temperature you applying some kind of energy, or you applying the some kind of temperature and raise the temperature by 1 degree, and this 1 degree Celsius is raised temperature is known as the heat capacity. Okay, the formula for the heat capacity is heat capacity, and heat capacity is also denoted as the capital C. Okay, heat capacity is also denoted by the capital C. The definition of heat capacity is Q upon delta T. Okay, charge upon change in temperature. You can write down the value of Q, what is the full form of Q and what is the full form of delta T. Okay, Q is the heat gain. Okay, and delta T is the change in temperature. And heat capacity is the extensive property. Extensive property is dependent on mass, amount of mass. If the mass changes, the heat capacity will also changes. So you can also write down the another point of the heat capacity. I can write down with the red color. Heat capacity is the extensive property. Okay, heat capacity is extensive property. Okay, what is the meaning of extensive property? The meaning of extensive property is the property which depend on mass amount. Okay, why it is heat capacity, why it is the extensive property. We suppose we can take one example of heat capacity. If you see the first beaker, in first beaker the capacity of holding the water is 1 liter. Okay, now I can fill this uh, beaker with the 1 liter of water. I have a second beaker, that capacity is 3 liter. Okay, I can also fill this with amount of water, and the third beaker is the holding capacity will be 5 liter. Correct, the amount is different in every, okay, every example has a different amount of water. Okay, suppose we consider A is the smaller one, B is the middle one, and C is the larger one. Okay, the mass is the different for the each one. First one, the mass will be the less. Correct, mass is less, mass is increasing. Okay, and more mass. Okay, highest mass. we already discussed heat capacity is a extensive property. Okay, if we provided some kind of energy, okay, if we provided some kind of heat, okay, on system 1, okay, if we provided some amount of heat on the B, okay, if we provided some amount of the heat on the C, but you can see in that bowl, the first one is uh, easily get heated if we apply the less amount of heat, but the last one is take time to heat, okay, by 1 degree Celsius. And this is this property is so that heat capacity is the ex, extensive property and is also dependent on mass amount. Okay, if the mass amount is increases, the heat capacity is also increases. Okay, the next point for the heat capacity is converted extensive property into the intensive property. Okay, because we can't calculate the extensive property of the heat capacity because the heat capacity is not dependent on mass amount. Okay, but the extensive property will show the dependence of the mass amount. Okay, now we can change. Next point is we can convert extensive into intensive property. Okay, what is the intensive property? Intensive property is not dependent on mass. Okay, after changing the extensive to intensive, the heat capacity will be divided into the two category. Okay, heat capacity is divided into two category. First category is the mass per gram. Okay, mass per gram. Okay, and second one is the molar per mole. Okay, molar per mole. In both the example, both the type, you can see if we change some heat capacity of the system in kg or in gram, the mass of the system will also change by the per gram. Okay, now second one is the molar per gram. We consider here the moles, and if we consider 1 moles and we find the heat capacity of 1 moles, then we also find the we also can calculate the number of moles, and for number of moles we calculate easily heat capacity of number of moles. Okay, for mass per kg, we can calculate the specific heat capacity. Okay, specific heat capacity, and it's donated with the capital S. Okay, and molar mass is find with the help of cm, like the molar heat capacity. Okay, molar heat capacity. Okay, what is the formula of specific heat capacity? Specific heat capacity, the formula is capital S is equal to C upon M. Okay, you already know C is the heat capacity, M is the molar. Okay, and you we can easily convert it S into C is equal to C, value of C, C is Q upon delta T. Okay, Q upon delta T multiplied by M. Okay, this is the final value of specific heat capacity. Okay, the unit of specific heat capacity is joule per kilogram. Okay, and for molar heat capacity, the formula of molar heat capacity is Cm is equal to C upon N. Okay, Cm, the value of Cm is Q upon delta T multiplied by N. Okay, and the unit for Cm is the charge value, the heat value is joule per kilo mole. Okay, this is the unit of molar heat capacity. Okay, you can mark, okay, as an important point. The next is heat is the path function. Okay, It's dependent on the path. Heat is a path function. Okay, heat is a path function. It dependent on the two path at constant volume. First one is at constant volume. Okay, and second one is at constant pressure. At constant pressure. Okay, at constant volume the heat the heat is the favor of the path function, but in at constant volume the formula for the heat capacity is q formula for the heat is q is equal to qv. Okay, at constant volume. At constant pressure q is equal to qp. Okay, we can write at constant pressure qp, and at constant volume in place of q we can write qv. Okay, now we have a uh, now we can also calculated the value of qv and qp. How we calculate the value of qp and qv at constant volume, at constant pressure? Okay, then we can use the first law of thermodynamics. Okay, according to first law of thermodynamics. What is the first law of thermodynamics? State that the first law of thermodynamics state that du is equal to dp plus dw. Okay, dq is equal to du minus dw. Okay, and what is the dq value? Dq is equal to du minus p dv. Okay, now we easily calculate the heat value of dq is equal to du plus p dv. Okay, and this is the formula for heat. Okay, now we can calculated heat using at constant volume. Okay, at constant volume, and at constant volume you can simply write down dv is equal to 0. Okay, if the dv is equal to 0, the value of dq is dq is equal to du plus 0, and dq is nothing but du. Okay, and if you integrated this value after integration, the value of dq is integrated with both side. Dq is converted into the q is equal to delta u. Okay, because we can't prove the internal energy, but we can prove the change in internal energy. Okay, we already seen in the first law of thermodynamics. First law of thermodynamics state that internal energy we can't calculate it, but change in internal energy we can calculate easily. Okay, in small amount. The value of qv at constant volume is du. Okay, and this is the final equation of heat. Okay, and we can write down as a one number, first number. Now we can calculate the value of dp at constant pressure according to according to first law of thermodynamics. Okay, what is the first law of thermodynamics? State that the first law of thermodynamics state that du is equal to dq plus dw. Okay, if we calculated the value of dp, the dq is equal to du minus dw. Okay, dq is equal to du plus p dv. Okay, we can easily calculate the value of p dv. Okay, now at constant pressure, at constant pressure, okay, we can easily calculate the first p dv. Okay, and p dv V is converted into the PdV. Okay. Now we can write down as a PdV is dq is equal to du plus p dv. Okay, dq is equal to d in bracket u plus pv. Okay, and you already know the value of enthalpy. Enthalpy is nothing but the change in internal energy plus volume, pressure into volume. Okay, this is the formula of enthalpy. Correct. Enthalpy is denoted as capital H. You can simply write down the value of H on the place of U plus PV. Okay. Then dq is equal to d capital H, dq is equal to dH. Okay. After integrating the value, after integration, okay, the value of dq is equal to integration of dH. Okay, at constant pressure, it's converted into the dp is equal to delta H. Okay, and this is the value of at constant pressure. Okay, if the question asked at the constant pressure, you can use this equation. If the question is asked on the basis of constant volume, you can write down the first formula for heat. Okay, now the heat capacity is now the heat capacity is formula for the heat capacity using at constant pressure, okay, and at constant volume. C is equal to q upon delta T. Okay, what is the q? Q is the dq upon dt. Okay, and this is converted into this. Now the heat capacity is also converted into the constant volume and constant pressure in the form of heat capacity. Now the value of heat capacity in the at constant pressure and constant value. Okay, simply you can write down here heat capacity. Heat capacity is also divided into the two part. You can find in the two different way. First one is heat capacity at constant volume. Okay, heat capacity at constant volume. Another one is heat capacity at constant pressure. Heat capacity at constant pressure. Okay, on constant volume, the value of Cv is integration of du upon dt. Okay, and du upon dt is nothing but delta u upon delta T. Okay, delta u upon delta T. Okay, change in internal energy versus change in temperature. Okay, for constant pressure, the Cp value is dqp divided by dt. Okay, after integration you can see that dqp is nothing but the enthalpy dH upon dt. Okay, and dH upon dt is the value of Cp. Okay, Cp यानी heat capacity at constant pressure. Okay, what is the relation between the Cp and Cv? Here the one question is arises from us. What is the heat capacity of, what is the relation between the relation between Cp and heat capacity at constant pressure and heat capacity at constant volume? Okay, you can see the formula for the relation of Cp and Cp is Cp minus Cv is equal to Nr. Okay, how could I find this value of Cp minus Cv or the relation between the Cp and Cv? Okay, This is there are two different way to find the value of Cp minus Cv. Okay, one is using one is using specific heat capacity. Okay, the formula for the relation of the Cp minus Cv is Cp minus Cv is equal to Nr. Okay, dividing dividing both side by n. Okay, after dividing Cp minus Cv is equal to Nr upon n. Okay, Cp upon n, Cv upon n, Nr upon n, and will be cut in Nr upon n. What will be the remaining value? Remaining value is equal to n is equal to W upon m. Okay, this is the value we have to remain. Now the next is Cpm upon W minus Cvm upon W is equal to R. Okay, if we put out the constant outside the bracket, then M is equal to Cp upon W minus M is equal to Cv upon W is equal to R. Okay, M is taken out as a constant value, and Cp upon M minus Cv upon M. Okay, this is taken into the bracket and is equal to R. Correct? Then what is the value of Sp minus Sv is equal to R upon M? Okay, this is the correct value of specific heat capacity. Okay, you can write down here. This is the value of specific heat capacity term. Okay, now the another one is we also calculated from the molar heat capacity. Okay, another point is Cp minus Cv is equal to Nr dividing both side by n. Okay, the value of Cp upon n minus Cv upon n is equal to Nr upon n. Okay, the final value of Cp upon n is Cpm minus Cv1m is equal to R. Okay, and this is the formula of molar heat capacity. Okay, this that formula are using for molar heat capacity. Okay, so I think you already know the all the points, all the fact about the heat capacity, all the point we discussed today. We already cover the entire points which are included in the heat capacity, like what is the general expression for the heat capacity, what is the specific heat capacity, what are the uses of molar heat capacity. Okay, we already discussed this all kind of topics in heat capacity. Okay, now we can solve some numerical, some problems of based on the heat capacity. Okay, the first question is which of the following will be true for Cp minus Cv is equal to alpha square Tv upon beta. Okay, now you have a option also. The first option is V square upon P. The second option is minus R. The third option is NR. And the fourth option is P square divided by T. Okay, now we can find using, there are two methods to finding the value of Cp minus Cp or Cv. If you see in any question like delta or alpha and beta, then you have to apply the second method. Second method says that alpha, value of alpha is 1 upon t. Okay, value of beta is 1 upon p. We already discussed in previous topic what is the value of alpha and what is the value of beta. You can simply put in the formula. Formula is Cp minus Cv is equal to alpha square Tv upon beta. Okay, the value of alpha is 1 upon t square. Okay, multiply by Tv multiply by p. Okay, and the value of beta is 1. Okay, 1 upon p, we can send them as a in numerator. The Cp minus Cv is equal to Pv upon T, and Cp minus Cv is equal to Nr. Okay, and this is the final answer. Okay, this is the final answer for this question. I think you already know the entire topic. How will you deal with the heat capacity? If any question are asked on the basis of heat capacity, you can easily solve. And if you if you watch my entire video, if you like my video, please subscribe my video and also share with your friends. Okay, thank you so much for watching my video.